Welcome to virtual GED class. Today we are going to be looking at ratios in word problems. Now, I'm kind of lumping this into the category of data analysis. Just to let you know, it didn't have to sit here, but it links into some other data analysis topics we're going to cover, so that's why I'm doing it in this unit. But this could work as a standalone class. Word problems are all over the GED, and they do tell you that you should expect multi-step ratio, rate, and percentage problems. That's one of the topics listed in your GED. So certainly GED study guide. So certainly an important skill to learn. So let's talk about ratios. We've got a few GED students with us here today. Helping us out. So let's go ahead and get started here. So first of all, what is a ratio? A ratio is simply a relationship between two numbers or more. Could be more than two numbers, but at least two numbers. Right now we have myself and 3 students in this virtual classroom, okay? And I will just let you know that we have 3 females, if you count me, and 1 male. Now, I'm not trying to make my one lonely male feel bad, but what I want to say is that this is a relationship. This is the current makeup of our classrooms. We have 3 females to 1 male. But what I'd like to say is that there's lots of ways to talk about this relationship. Just saying 3 females to 1 male isn't the only way. Can anybody else think of another way to express this idea?
Oh, 1/3.
1/3. So 1 male
For every 3 women.
every 3 females.
Yeah.
So you could express it as a fraction. I absolutely agree. I could express it as a fraction. That's not the only fraction I could use to express this relationship. There's other ones, and there's other types of numbers as well. Can anybody think of another way that we could express this relationship?
It will be 4/3.
4/3, so 4 students, I guess you're saying then.
Yeah,
Do I count as a student? Maybe we should say participants. I'm not really a student, am I? So 4 participants to 3 females. Sure, I could say that. Any other way I could talk about this relationship?
It will be the same like 3 + 1, 2.
3 + 1. So like 3 females
Males plus 1 male.
plus 1 male make up 4 participants. Sure, I could say that. How about another way? Maricela was here. The other 2 of you are joining us in the middle of a data analysis thing, but we did this with percentages. Maricela, could you tell me something about the percentages of males and females in the class?
Yeah, like 75% of the class is female.
Okay, so 75% female. How about male?
25%.
Absolutely. Now, there's still lots more ways. Any other way you think of that I could express this relationship? Are we out of ways? Could anybody think of a diagram or a picture I could draw to express this?
A pie graph? No?
Sure, a pie graph. I could have a pie graph. What would a pie graph look like if I were trying to represent the males and females in class?
It will be on 4.
1/4 would be labeled what?
That will be male.
Males. Awesome. And then the other part I would label
Female.
females. And maybe this is, I don't know. I don't want to write our class's sex up here because people will get the wrong idea all over the internet. But y'all know what I mean. Maybe I should say gender, even though this isn't technically exactly what I meant. But okay. So yeah, I could do it as a pie graph. Oh, yeah. Any other way I could draw this or think of this or picture this? Oh, it was interesting because Maricela, when you told me how to draw this, you said draw a quarter. So what you're telling me is that a quarter of the class is male?
Yes.
Oh.
Even we can, yeah.
Okay. So I'll write that. A quarter of the class is male. Sorry, I spoke over you. What did you say?
Even if we put it in 4 parts, it's still like 3 parts will be the same, like in the top.
3 parts would be what? 3 out of the 4 parts would be?
Yes, female.
Female, okay. I was watching someone do this in a demonstration the other day, and somebody said you could draw little men and little women, and I was like, I sure could. I could make a pictograph. So one of the hardest things for a lot of students is that there's so many different ways to talk about this relationships in math. So right now we've seen us doing it with words. We said 3 females to 1 male. I did it with a word. I did it with a fraction. in a lot of these examples. I did it with a percent. I did it with various types of diagrams, okay? And I even used a colon at one point when you said to me 4 participants to every 3 females. And so there's a lot of different ways to write ratios, and students can find this confusing because they want to know what the right way is. Students are, what's the right way, Kate? You know, what will actually be on the test? And I always nod. I'm like, they're all the right way. And any of them are fair game for your test. They could all show up. So we have to be able to think of relationships in lots of ways. Let's look at the 3 main ways that ratios show up on the GED. And on the GED, ratios are commonly expressed. And this, again, is just commonly because you could certainly see a pie graph, you could certainly see a pictograph, but they're commonly expressed one of 3 ways. The first and most common way, and so I'm glad that David brought it up, is as a fraction. For example, if they say a language like write a ratio to represent the number of females out of our class, I'm expecting when they say, you know, write a ratio, I'm expecting to see a fraction. Most commonly, that's how that answer would be expressed. Now, it's certainly not the only way to express it. Second common way you might see is with that colon that I showed you. Okay, so for example, 3 out of every 4 in our class are females. So 3 females to 4 in a class. With a colon, that would look like this: 3 females to every 4 in the class, or 4 participants, same deal. And the third and final way you're likely to see it is using the word to. They love, love, love word problems on the GED, and so you will commonly just see it written in words, you know, 3 females to every male. Now, this is a different ratio. I could have just as easily said 3 females to every 4 participants. Maybe I should have. Actually, I think I will. You guys get to put up with me learning to be a better teacher as I teach. I just want you to see that changing the wording didn't change the scenario any. I can talk about the same ratio, or the same ratio 3 different ways, but with a fraction, with a colon, or using the word to. They all say the same thing. Let's look at some typical GED style examples. But before we do, I just have to warn you of one thing. And so David and Debbie haven't heard this because they haven't been with us before, but Marycella's heard me say this many, many times. Marycella, we've said it again and again and again. Final fraction answers. We said when we had an answer that was a fraction, we always had an additional step to our problems. Do you remember what we've always said about final fraction answers? They must be reduced. Reducing a fraction to lowest terms is part of the simplification process. And since mathematicians always like their final answers as simple as possible, we will reduce all our final fraction answers if they can be reduced. That being said, you guys are at a disadvantage. We have not done fractions in my class. Some of us know how to reduce them by hand and some of us don't. So what I'll tell you is that your TI can reduce fractions. It's super easy. In fact, your TI is so super smart that it knows all final fractions must be reduced. All you have to do is input a fraction and it will automatically reduce it. That's how smart your calculator is. You don't even have to press a button that says reduce. You just have to input the fraction and it will reduce it. And so I will just remind you to input a fraction. We use the N over D button. You type in whatever number you want in the numerator. For example, it could be, let's do 3 and 4 for our first example because something interesting is going to happen. You could put 3 on the top, you could put 4 on the bottom, arrowing around, and then you would just press enter. Now this one's a silly little example because I hope you guys know that 3 out of 4 does not reduce. 3 out of 4 is already in the lowest terms it's going to get. So 3 out of 4 is 3 out of 4. When you press enter, you get the exact same answer, 3 out of 4. But let's try it with one more example. You guys can practice inputting this for me. Let's imagine that we had a different relationship. I want the relationship, let's pretend like it was a really bustling class. For once I had, I don't know, 20 students show up, and 15 out of 20 were female. So go ahead and put that fraction in for me. Again, press the N over D button. Type 15 on the top, arrow down to press 20 on the bottom, and then press enter. And let me know if that doesn't work, because if it doesn't work, it's because you're in the wrong mode.
I think it works.
It should reduce also to 3 out of 4.
Okay.
Press N over D, N over D. And I want to know, did you get a nice horizontal fraction line or did you get a diagonal one?
Diagonal.
You're in the wrong mode. Okay, so fractions work better in math print mode. It's not that it won't work that way, it's just more confusing to type in. So do me a favor, hit mode on your calculator.
Okay.
You should see on the last line of mode, there's a choice between classic and math print. Do you see that? Arrow over until you're on the word math print and then press enter to select. So use your arrows here to get to the word math print and then press enter to select.
When I hit enter, should all those words go away?
No, it just will be black on math print now. To make all those words go away, press clear. Now try pressing the N over D button. Did it give you a nice horizontal fraction bar?
Yes.
Yes, now you're in the mode I would want to be in for doing fractions. So type 15 on the top, arrow down to type 20 on the bottom, and then press enter. Get 3/4.
Yep.
Wonderful. We learned to reduce fractions in our calculator. For those of you guys, whether you're on the internet or in my class right now, who don't know how to reduce fractions, that's okay. If you have any ratio word problems on the GED, you will have this calculator. So we'll use this calculator to help us along as we work today. And we'll be using that little function a lot. Okay. I have to say that many ratios are equivalent. Guys, what does the word equivalent mean?
The same.
Yeah, the same, equal, they're equal to each other. So we actually just saw that. We typed in two different fractions, 3/4, and it reduced to 3/4. But then we typed in 15/20, and it also reduced to 3/4. And a lot of students, this is one of the struggles that they have wrapping their brain around ratios. How could 3 out of 4 be the same as 15 out of 20? And the idea is that the same relationship can repeat. I'm going to say that again. The same relationship can repeat. Let's talk about what these numbers meant. When we did this ratio on the last page of 3 out of 4, we said that our 3 were the females in our class and the 4 were our total participants. So when we drew it out in a picture, which was actually my favorite way of looking at it, what I'm trying to say here is that we can repeat this relationship as many times as we want, giving us many equivalent ratios or equivalent fractions in this case. So this is the ratio of 3 out of 4, yes. But I could keep repeating this relationship, drawing this same picture again and again. And in fact, I need a copy and paste function on my little thing because I don't want to draw it again and again. But I just repeated the relationship. Now, I drew the exact same relationship. On the second line, I again have 3 females and 1 male. Can you guys see that?
Yes.
Yes. But now, how many total females do I have now? If I look at both lines.
6.
6. Out of how many total participants now?
12. Or no, 8, sorry.
8. There we go. So even though I have different numbers of students in the class, it's the same relationship. Out of every 4 students, 3 of them are female. And I could keep repeating that relationship again and again, giving me many, 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 in fact, an infinite number if I had all day for the rest of my life to draw, but I don't. And I could find an infinite number of equivalent ratios. And that is the reason why all us mathematicians got together and said, oh my gosh, I wasn't really at this meeting. It was before I was born, y'all. But, the mathematicians decided amongst themselves, we have so many ways to say the same thing. Talk about that same 3 out of 4 relationship. Which one should we use? And they said, we'll just use the simplest one. And that's why I say that all ratio relationships should be expressed as simplified. So warning, it's not only with fractions that this happens, but our calculator only knows how to reduce fractions. So that's a little dramatic. Like, for example, they could say 25 out of every 30 students falls asleep in Kate's class. I don't know how they do it because I am so loud, but they manage anyway. So 25 out of every 30 students fall asleep in Kate's class. And now they might ask you a question on the GED, like what is the ratio of sleeping students to total students? But remember I said fractions aren't the only way to write ratios. You could also use it with the colon or the word to. So what if the answers here were not in fractional form? So, we get a lot of multiple choice problems on the GED. Here are 4 possible ratios. They don't even involve the numbers that we have. We have the numbers 25 and 30. None of them have a 25 and 30. How could I even deal with this? Okay, so the thing is even if it's not expressed as a fraction, if it's expressed as your ratio is written this way with a colon, you could still reduce it. Okay, and your calculator, if you're going to do that in a calculator, you have to treat it like a fraction. So that's what I'm going to do. I'm going to write it as a fraction, then I'll compare my answer to this, okay? So they asked us, what is the ratio of sleeping students to total students? So if they want ratio of sleeping, I'm going to have to put the sleeping on top. To total, I'm going to have to put the total on the bottom. So help me out. How many students are probably sleeping according to this word problem?
25.
25. Out of how many total students?
30.
30. So there's my ratio of sleeping students to total students. Now this, because it is a fraction, I can type into my TI calculator, and I'll do that in order to reduce it. And I get this, 5 sleeping students to every 6 total students. So now which one of these answers says the same of it as this? Well, obviously it's not C or D, it's A or B. And you might wonder about order. So you read a fraction top to bottom, and you read a ratio left to right. So if I started here with the 5, I need to start here with the 5, and B is the correct answer. So you could still use your calculator to help you. Okay, so just an FYI, I'm going to start with simple one-step problems. But as you guys know, the GED does not tend to feature one-step problems. They like complexity. Okay, so we're going to graduate to some more complex problems by the end of this lesson. Okay, so let's take a look at number 1. It says a bag of marbles contains 5 blue marbles, 7 yellow marbles, and 11 green marbles. And then they ask us, what is the ratio of blue marbles to yellow marbles? Now, they already expressed that ratio with words, but we have 2 possible ways besides the words that we talked about expressing these ratios. We could do it with a fraction or with a colon, and I don't care which way you do it, and it could be either way on the GED. It would probably be multiple choice. So what is the ratio of blue marbles to yellow marbles? Well, I'm just going to go in the order they asked me to and make a fraction. I'll start with the blue, and I'll put that over the yellow. Super duper simple. So we've got 5 blue marbles. We've got 7 yellow marbles. So what is the ratio of blue marbles to yellow marbles? It's 5 to 7, and you could write it that way, or you could write it this way. They both say 5 to 7. Super simple question. Do remember that you should make sure that all final fraction answers are reduced. Now, I'm really good at reducing fractions in my head because, hello, I do math 10 hours a day. I could tell you that this is already reduced, but if you weren't sure, you could again put N over D, type the 5 on the top, the 7 on the bottom, and press enter. And you might be thinking, Kate, are you going to teach me to reduce fractions? And for you guys, my students who are in my registered online class, that's an Odysseyware. You go through it, and if you need help, I'll certainly help you with it. But I will never focus on it in the virtual GED class because it's such a small part of your GED, and almost every time you have a fraction, you have a calculator. So I choose to focus on those things that come up more often. So anyway, when I type 5/7 in, I still got 5/7, so we're good to go. So then let's look at B. B says, what is the ratio of green marbles to total marbles? So 2 ways I could write this. How could I write this?
11 over 11, right?
I love your 11.
Or no, 11.
12. 11 over 12.
11.
Yeah, I have an unknown number for the bottom. That's the problem. They want green marbles to total marbles, and nowhere in my problem does it tell me what total marbles are. So that means I'm going to have to use what I know to figure out what I don't know. How could I figure out the total marbles?
You add all the numbers together.
Exactly. I could add up my blues.
So 7 plus 11.
Absolutely. My yellows and my green. When your numbers are different, the quickest way to total, or the only way to total really, is just to add them all up. So what do I get? 23?
Yeah.
Is everybody cool with that? Is anybody mad at me?
Nope.
Much more likely type of problem than A. They're going to include numbers that you have to go searching for a little bit. They won't necessarily be clear to you. Okay, once again, you should, whether you write it like that or you write it like this, if you're not sure, you should see in your calculator if that one reduces, but I promise you 11 over 23 is 11 over 23. It does not reduce.
So on the GED, do we have to write it just like you did where you wrote the green?
No, this is my work. This is me organizing my work.
Okay.
I always like to make a plan with word problems because what I have found about GED students is that most of them are so used to being bad at word problems that they just automatically pick up their calculator, start mushing things together, and hope and pray they just mush the right numbers the right way. So you will often see me start with a verbal plan of what I'm going to do before I put those numbers in order. And on the GED, the answer could be written either of these two ways here, with the fraction or with the colon. So I just want you to see it both ways, but I don't have to write both. They're both equally as good and equally as correct. I could write either or. I don't know why I kept doing this, because it's the same basic concept again. So we should be real quick about C. What is the ratio of green marbles to blue marbles?
11/5.
Absolutely. 11 greens over 5 blues. That's the relationship. I just spent an hour on the phone with tech support trying to get my pen not to spray anymore. And I swear it was not spraying at the end of yesterday, but here it comes back spraying again. I'm sorry. But yes, 11 green to every 5 blue. And what is the ratio of yellow marbles to other colored marbles? Now I'm being a brat. Look at me. So the first part's easy, the yellow part. What number shall I use for that?
7.
7. But how about that phrase? I want yellow marbles to other colored marbles. What am I talking about if I say other colored marbles?
Either the green or the blue.
Exactly, the green or the blue. So how many marbles is that?
16.
16. How'd you get that number, Debbie?
Add the 11 and 5.
She added the green and the blue. Very nice. So pretty simple examples, and none of these reduce, so nice. So number 2 says, a sock drawer contains 5 pairs of black socks, 10 pairs of white socks, and 15 pairs of patterned socks. You might be thinking, why are we doing this again, Kate? Well, sometimes they do reduce. So let's take a look. It's A says, what is the ratio of white socks to black socks? So pretty easy. We already know white is 10 and black is 5. That's why I wanted to do this problem, because it's a little tricky, because I want the ratio of white socks to black socks, and something really funny is going to happen if I type this into my TI. Okay, so students who don't know how to reduce fractions by hand are actually at a disadvantage on this particular problem, because if I type 10 over 5 using my N over D button and press enter, take a look at what happens.
That's 2.
Yeah, you just get the number 2. And so I have to tell you something. Yes, it's true that 10 out of 5 is 2, but 2 is not a ratio. 2 is what we call a whole number. It only consists of one number there, not a relationship between two numbers. So I would not write my final answer as 2, even though my calculator is telling me 10 over 5 is equal to 2. Yes, that's true. Okay, but you need to ask yourself, to what? To what? You know, it's a relationship we're looking at. It's 2. Okay, so let me just show you what I mean here. There's 2 ways to think about this. The first is, if you know how to reduce fractions by hand, you could do it by hand and see what I mean here. Both 10 and 5 are divisible by 5. They both divide by 5. So I could divide the 5 out of both of them. Then I would see the 2 on the top, but on the bottom, I would see 5 divided by 5 is 1. So when I say 2, yes, it's 2 one whole things, but in this case, because I'm talking about a relationship between white socks and black socks, I needed a number for the black socks. So the 2 represents what? The 2 represents the white socks, and the 1 on the bottom represents the black socks. I need those 2 numbers so I can see the relationship between white socks and black socks. Does that make sense? Now, even if you're like, Kate, I never reduced a fraction by hand in my life, I don't even know what you were doing with that divide 5, 5 nonsense. What is that? I still say that even if you got a 2 out of your calculator, we know that when you say 2, that's 2 whole things. You know, just the number 2 means 2 whole things. And so that's like a 2 in the ones place. So 2 what? 2 ones. And so that's what the bottom of a fraction tells us, the size of the thing we're looking at. And so a general rule of thumb, and to write this down if you don't know this, is that any whole number is over 1. So you know what? If you got an answer like 15 out of your calculator, that's 15 out of what? 15 over 1. If you got a whole number like 4 out of your calculator when you reduced your fraction, that's 4 out of 1, and so on and so forth. If they were to ask me what is the ratio of white socks to black socks, I would either answer like this, 2 over 1, or to avoid confusion, I would more likely put 2 to 1 like that. And either one of these answers are perfectly legit. But this, just 2 by itself, is not a legit answer, not because it's not true, but because it's not what they asked me to do. They asked me for a ratio, and a ratio is a relationship. One number is not going to be in relationship with itself. So then B, let's do that. What is the ratio of black socks to patterned socks? So remember, order is important. You're going to want to start with the black socks. How many black socks are there?
5
5.
over 15.
Out of 15 patterned? Nice. Now, even though this is absolutely true and absolutely right, if you put this down and as your answer on the GED, you'd get marked wrong. Why? Because it's not finished. All mathematicians, your final answers are simplified if unless otherwise requested. And so we would want to make sure that our final fraction was reduced. So 5/15 reduces to 1/3. So there's 1 black sock to every 3 patterned socks. So sure, that pattern repeated 1 to 3, 1 to 3, 1 to 3, but that's still the basic gist of the relationship. So pretty easy, right? Compared to some other skills we've done, this is not so bad. We'll do one more simple one and then we'll look at some more complex ones. So let's look at C. It says, what is the ratio of patterned socks to total socks? So the ratio of patterned socks to total socks. What number should I have on top of my ratio?
15.
Absolutely, there's 15 patterned.
15.
And then what will I put on the bottom?
And then 30 underneath.
30. Where'd you get that lovely number, sir? I don't have a 30 in my problem, so where'd that 30 come from?
Is all the socks?
10 plus 15 plus 5.
Absolutely. The total
30.
is found by adding up all the socks. 30. Great. Okay, and now I can see it in a heartbeat, but if you can't see it, you could type it into your calculator, but 15 over 30 is the same as half the socks. If I have a drawer full of 30 socks, half of them would be. So my fraction now, or my ratio now reduces to 1 out of 2, or 1 out of 2, patterned to total.
So do we always want to try to reduce it to make sure
Yep.
it can't go down anymore so we don't get it wrong?
Yes, that's what I would do, especially with my students who struggle with reducing. Just might as well type it in there and see what happens. Yeah, so I'm really good at reducing in my head because I do it all day long. I teach it. Hello, I can usually see it. I don't even have to do any work. But usually a lot of my students miss reducing, especially when it's like a times table they're not good at, like pulling out 3s or 7s or 11s, you know. They just miss them. And so it would be easier to just type it in your calculator just to be sure, since you have it anyway.
Okay.
The other thing you're going to notice, Debbie, is that when you're focused really, really hard on things like challenging skills like interpreting word problems or doing algebra, you'll forget basic math. You'll get mad at yourself. Like, how come I just said 1 + 1 was 7? And it's because so much of your mental real estate is dedicated to the challenging concept. Your brain will actually like go, turn off all other functions. We must focus. So the calculator is nice. Okay, now I'm going to show you another example of how this comes up on the GED. Even though it doesn't specifically say ratio, they have what they call scaled drawings or scale problems on the GED. So scaling, like they do on maps, is a ratio issue. So has anybody here ever seen the blueprint of a house?
Yeah.
No.
Okay, did you say no, Maricela?
Yes.
Okay, so blueprint of a house, what's another way we would see scaling? A map. I'm sure you've looked at a map before. Okay. On a blueprint of a house, I don't print it out house size, right? I'm getting an extension built on my house right now. And believe me, the blueprint, although it is a large piece of paper, is a lot smaller than the house. They scale it down. Now they keep it to the same proportion so that my person knows how to build my house and it works, but they scale all those proportions down. And that's a relationship between the real life house and the scaled down drawing. And so ratios can be used to express these relationships. Does that make sense?
Yes, can you say that word again? Because I understand now, but I never heard that word before.
The word scale.
Scale, okay.
Okay, scaling, like the scale you step on to check your weight. It's spelled the same way, but we call them scaled drawings. You can scale up, you can scale down. Number 3 is like that. It says, according to the key of a street map, 2 inches is related to 5 miles. It's 2 inches to every 5 miles. So what am I saying? I'm saying 2 inches on the map is 5 miles in real life. Does that make sense?
Yep.
So then I say if two buildings were 10 miles apart in real life, how far apart would they be on the map? Now, I haven't taught you any problem-solving skills with this kind of problem yet. We'll be looking at more complex examples of this later and learn like a method, but right now all we have is what we know that this relationship means. So what we know now is if we see 2 inches on the map, 2 inches is the same as 5 miles. But
So
we have these 2
2
buildings, they're further than 5 miles apart, right? They're how far apart?
They're 10.
They're 10 miles apart. So how many inches apart would they be on the map?
Wouldn't it be 2 inches?
Well, 2 inches would only be 5 miles apart. And
It
they're
would be
more than 5 miles apart.
Oh, then 4.
4.
4, where'd you get that?
2 is 5. So, and I just put in my line, it would be 4.
Yeah, for every 5 miles, we'll get another 2 inches. I drew out a diagram here. This first 5 miles represents 2 inches. This next 5 miles gives me another 2 inches. So those 10 total miles will be represented by 4 total inches. Does that make sense?
Yes, it's how I did it, so that way it's easier.
Yeah, you pictured it. Yes, that's wonderful. I'm super glad you could picture it. That is the base level skill here. However, just to let you know, I've seen ones on a GED practice style problems where it was like 2 1/4 inches is equal to 7 1/2 miles. And I was like, oh, that one's a little harder to picture. So we will learn some more advanced mathematical skills to go along with those advanced style numbers, besides just drawing a diagram. But for now, we need to be able to practice what this just practically looks like. Okay, so let's do one more that we could picture that way. If the park and the library were 1 inch apart on the map, so now, okay, I don't know. What's a park look like? It look like a tree? That's my very beautiful tree. You guys see I'm a math teacher, not an artist. And here's my library. You know, it's a building that looks like a book. Okay, so they're only 1 inch apart on the map now. How many miles would they be apart in real life?
Oh, you'd have to divide 2 into 5, right?
You'd have to, I love that reasoning, but there's no 2 here. What made you say that you wanted to do that?
The 2 inches for every 5 miles, but it's only 1 inch, so you're taking half of the 2 inches.
Yeah, he's saying, well, if I had this 2 inch being 5 miles, but I only want half of that, half of 2 inches is 1 inch, then I'd have to take half of the 5 miles as well. And you did it a very brilliant way by dividing by 2. Instead of taking half of it, you said halving something is the same as dividing by 2. And so that would be 2.5 miles or 2 1/2 miles, same difference.
Sweet.
Brilliant. Good reasoning. I haven't taught you any math skills yet with that or any algorithms. You just had to straight up use your reasoning process. Very nice. And I'm going to teach you like a mathematical algorithm in the next class. That's what I'm leading up to. If the picturing it was a struggle. David, have you ever done any kind of construction work or physical labor, like where you're building things?
Yeah, framing, landscaping,
There we go.
concrete work, you name it.
So that's why he's got that reasoning process down, because this is a real life skill used in those industries. So a certain paint is mixed using 2 parts blue paint, 3 parts gray paint, and 5 parts white paint. Now, remember I said to you that a ratio was made with at least 2 numbers, and I had to allow that sometimes it's more than 2 numbers in the relationship. Here's a great example. I want 3 colors of paint. Guess what? That puts 3 numbers into this relationship. So I asked you an interesting question. What is the ratio of blue paint to gray paint to white paint? And if you tried to write this as a fraction, it would not make sense, right? We do not have triple tiered fractions, okay? You don't get to write a number above a number above a number and have it make a whole lot of sense to you. Okay, so I'm not going to use a fraction to represent this. So
what
just
about a mixed fraction?
say that again.
What about a mixed fraction? Couldn't you do 2 and 3 over 3?
Oh, yeah, no, that would not be the same relationship. The
No.
whole number is out of the relationship in a mixed number.
Okay.
The relationship is between the 2, and the whole number is a totally separate thing.
Okay.
Does that make sense?
Yeah.
So I would not want to even use a mixed number. What I would want to use is use the colon every time. So the ratio of blue paint
Okay.
to gray paint to white paint. I'll just put colons where my words to are and go in that order. So blue paint is 2, gray paint is 3, and white paint is 5. So it's the relationship is 2. Now that's an ugly one. And then I asked you a really weird question because I'm a brat. Find at least 3 ratios that are equivalent to that ratio. Now, I told you there's an infinite number of equivalent ratios. And literally, I could write an infinite number of equivalent ratios. So just asking you for 3 is only asking you for a few. But you still have to use some reasoning here. And so a lot of students struggle with this, especially your calculator won't be able to handle 3 numbers at once. So that's where drawing a picture can really come in handy. So I'm going to do that. Instead of drawing little gallons of paint, since I'm not an artist, I'm going to do 2 Bs for my 2 blues, 3 grays, and 5 Ws.
Okay.
So there's kind of a visual representation. And I said, as long as you repeat this relationship, you're just going to keep coming up with equivalent relationships, as long as it's the same ratio. So I would just repeat this strip again. There's a fancy name for this type of problem solving that Odysseyware will probably teach you. I think they call it tape diagrams or something, whatever. If you just repeat the same pattern over and over again, I don't care what you call it, you're going to end up with equivalent ratios. Does that make sense?
Yeah.
So after the second row here, I have an equivalent ratio. Now I have 1, 2, 3, 4 blues, to 1, 2, 3, 4, 5, 6 greens, to 5, 10 whites. How about after the third row? What's another ratio that I could write?
That would be
3 rows.
It would be 6, 8, and 12.
I like your 6.
Oh, 6, 7, 8, 9.
6, 9, and actually 15. I'm
15.
counting by 5s here. 5,
Oh, yeah,
10,
you're right.
15. So then what would be another one?
It would be 8, 12, and 20.
Exactly. And you could just keep drawing this relationship as many times as you wanted to or needed to and keep coming up with equivalent ratios. Does that make sense, Maricela and Debbie?
I'm lost.
Oh, are you lost about where my numbers are coming from, or are you lost about what I'm writing, the letters that I'm writing?
Yeah, I read the letters, but I'm lost in the numbers because.
Okay. So after each time I wrote a new row, I recounted up my blues, greens, and whites. So let's look and imagine I only had 2 rows written. So let's count it. Now I have how many blues? 1, 2, 3, 4 blues. And so I wrote a 4 here. Does that make sense?
Okay.
Yeah. And then how many greens? 1, 2, 3, 4, 5, 6 greens now. So I have a 6. And then how many whites? 10 whites now. Good. And I could just keep adding a row and recounting and adding a row and recounting. That would be the most visual way to picture ratios. It's certainly not the only way, dear Lord, but it is a very visual way. We'll be looking at a more mathematical way next class. Okay. Is everybody okay with that?
But the answer here would be 4, 6, 10, 6, 9, 15, 8, 12, 20.
Yeah, because I asked you for at least 3 ratios that are equivalent to that ratio. Now, The thing is if this was on the GED, it wouldn't be phrased like this. What would happen is you would write a ratio and their multiple choice answers would look different than yours.
Yeah.
Like, oh, crap. My answer's not here. What do I do? So I want you to be able to see that all these answers are the same relationship.
Okay.
And so that you can spot equivalent ratios when you see them. Does that make sense?
Yeah.
Okay, cool. And Odysseyware has some similar kinds of problems. Lots of practice for you guys on this. But tape diagrams, whatever way they teach them on Odysseyware, people usually end up confused. So that's all they mean by this, is drawing a picture to represent so you know what you're looking at. And for the rest of the internet, y'all don't need Odysseyware, okay? People out there like, I don't have any Odysseyware. That's okay. This is not a huge part of the GED, but it is useful to know. Okay, is anybody mad at me?
Nope, you're good.
Okay, shall we look at number 5 then? Number 5 would mess with your head. Mess with a lot of students' heads. A certain machine at Brett's Bagel Emporium produces 3 defective bagels out of every 500 produced.
Okay.
Another machine has 1 defect per 150 bagels. And then I want to know which machine produces less defective bagels. I'm asking you to compare ratios. The GED loves having you compare fractions, decimals, ratios, slope. It's their favorite. So this is so GED typical. Okay, so how do we even compare a ratio? Let's write them down first. Let's look at the first machine. What's the ratio I see in the first machine?
3 to every 500
Yeah, 3 what? That 3 represents what?
defective bagels.
Absolutely, 3 defective. And that 500 is what?
That's every 500 bagels produced.
Exactly, the total bagels, all of them, the good ones, the bad ones. Beautiful. Now our second machine has a different relationship. The relationship there is
1 out of 150.
1 defective bagel out of every 150 total bagels. Now I'm asking you, which one produces less defective bagels? And students make a really bad assumption about fractions, yo. They assume big numbers means big value. And that's simply not true, because a fraction or a ratio is a relationship between 2 numbers. You know, just because, like we saw here, these numbers were getting bigger and bigger and bigger, and yet the relationship was the exact same relationship. The value wasn't getting any bigger. So I'm asking you to consider the relationship between these numbers here. Okay, there's a lot of ways I could do this. Probably the easiest way is it's much easier to compare decimals than to compare fractions, or ratios are, you know, a form of fractions. And so one way you could do it is by converting to a decimal in your calculator. Super easy if you remember what a fraction bar means. Now, Debbie and David are at a disadvantage because they haven't been with us, but do you remember, Maricela, what mathematical operation a fraction bar means?
Division.
It does. Oh, David says, I know. Fraction bar literally means division. So you could convert these into decimals by doing the division. I'm going to do it. I'm going to do 3 divided by 500.
Okay.
And I get
Wouldn't it be the other way around?
0.006. Again, I just pressed divided by for the fraction. And 1 divided by 150. And I get 0.0066, yada, yada, yada.
What's the line on the top?
Here to compare the decimals. Okay, which one of these produces less defective bagels? So which one of these ratios is smaller?
The first one?
The first one, absolutely. It's just straight up 6 thousandths with nothing after it. Now this one had 6 thousandths, but then it had more after it. It also had 6 10,000ths,
100,000.
100,000ths, and so on and so forth. Is
100,000.
everybody okay with that?
Yep.
Debbie, are you okay with that? Because traditionally comparing decimals is also tricky for students.
Kinda.
Kind of. Yeah. So a lot of students like don't know where to look. So you can compare 1 digit at a time. So I literally put my fingers over and look and compare the ones place. Okay, they're both zeros. Let me show you what I mean. I'll like put my finger right there and just compare. Okay, they're both the same. They're both zeros. And then I move on to the next digit. Okay, they're both zeros. You know, and it's kind of like when you're filing in alpha order. Have you ever filed anything in alpha order, Debbie?
Yeah.
If they both start with A, B, E, you're going to ignore the A, the B, the E, and you're going to look at the next letter. Oh, this one's a J and this one's a T. Okay, the J one will come first. So you just keep comparing a digit at a time until you get to where they differ. And so that's what I was doing here. So I compared the 006, 006, they were all the same. So then I got to the next digit, there was nothing after it, so that one was a 0. But this one had a 6 after it, it's higher. Make sense?
Yeah.
Okay, cool. And I'm not trying to make you feel bad, Debbie. I just know where students usually get stuck here. So apparently David is proficient at comparing decimals too. You're just good at everything. We're going to figure out you don't need me. I don't know. Okay. Are we good with this page, guys?
Yes, just
Yeah.
I did different. I don't know, maybe I just confused myself, but I did I multiplied 153 times.
Yes. So you found out this one would do 3 deficits per every 450 bagels. And Maricela, there's often more than one right way to do math. The way you did it is actually how I would do it if I was doing it in my head. But, you know, it's not the way that is easiest for most students. So I like that you did it that way. It actually tells me that you're kind of leaning towards mathematician. You said in this one, I'm going to get 3 deficits for less bagels, so I'm going to end up with more defective bagels. And you, that was a right line of thinking too. You just thought about the problem a different way. Okay, is that good?
Yes.
You came up with the same answer, right?
Yeah.
Yeah. So,
The first one I did in the calculator, and the other one I just multiply.
Okay, cool.
Thank
And
you.
that's totally fine. I'm totally leaving that in the video, Maricela, because I think that a lot of students like you would think of that a different way. And that's a beautiful way to do that. Okay, now you know when Kate gets to write word problems, Kate shows up all the time because Kate's the center of the universe. So here we go. Out of the 32 employees at Kate's Cheesecakes, guys, I'm looking for a new job apparently, 22 are female. Now, I could use language that maybe isn't so clear to students. That's what I wanted to point out. Look what I say. I said, what ratio of the employees are female? This time I didn't say something to something. So what number do I put on top? What number do I put on the bottom?
22 and 32.
Yeah, absolutely. You're right. It is 22 out of 32. How'd you know that? What about 22 made you want to put it on top?
Well, reading the problem, it says out of 32 employees. So there's a total of 32, and then 22 of them are female. So 22 female, and then the total 32.
Wonderful. And like we saw in percentage problems, when you say what ratio of the employees, that of word is usually the total that we're talking about there. So yes, what ratio of the employees are female? 22 out of 32 employees are female. 22 females out of 32 total employees. And this is the most common type of ratio. I think Odyssey Ware calls it a part to whole ratio, but again, you don't need to know any language for the GED. But this is the most common type of ratio where we have a piece out of a total. And we also see that a lot in probability, like what happens on the science. They have these kinds of problems.
No, I'm still confused on this one on how to get that.
How to get that? Okay, so here's some clues, Debbie. The word of, when I say what ratio of the something were something, is usually the total. It signifies that that's the total. And you want the total on the bottom of the fraction.
So when you see the word that's saying you're
It's
looking
like saying out of, you know, so many out of. So what ratio of the class? What ratio of the employees? What ratio of your paycheck? Where that of represents that total. And then you use the to be verb, like is female, is spent on groceries, are eaten up in a week. That's talking about the piece. Does that make sense?
Yeah.
And you'll put the piece on the top and the total on the bottom unless told otherwise to do so with that to language. So this is the most normal way to do a ratio, with the piece on the top and the total on the bottom. Now, it's not the only way, but I would have to specifically direct you with my blank to blank language to do it another way. So then let's try the next one. What ratio of the employees are male?
10 to 22.
10 to 22. Now, I love it that you knew that number 10, but I always, anytime you guys come up with some number I didn't give you, I want to know where it came from. Where'd you get that 10 from?
Oh, I'm sorry. I was reading C. It's 10 to 32.
Oh, okay. I still want to know where that 10 came. I hadn't even talked about the bottom yet. Where'd that 10 come from?
I subtracted 22 to 32.
Yeah, so what is David saying over here? He's saying that if we have 32 total employees and 22 are female, we can assume that all the ones who are not female are male. And maybe you guys on the internet are saying to me, Kate, this is the modern world. You can't assume that anymore. But the GED has not modernized yet, okay? So assume if they are not female, they are male as far as your test is concerned. Okie dokie. So I just removed the part I didn't want, the females, and the rest, subtract, are male. So 10 out of 32. Oh, hey guys, I got so distracted last problem in part A with my own talking, I forgot to finish the problem. I'm fired.
Oh, you got to reduce it.
What did I forget to do in part A?
You got to reduce it to
I gotta
11.
reduce it, and whether you do it by hand or in your calculator, it needs to be done.
It's 11 over
Yeah.
18. No.
11 out of 16, actually.
Yeah. Mental math.
Mental math.
Not very good at it.
I got so many tricks. If I had 4 years with you guys, I would teach you all my mental math tricks. I'm faster than a calculator. But because I have only a short time with most, you guys won't last more than 3-4 months. I try to get as much GED math into you as I can. That's why I let you reduce in a calculator. But if you were going to be with me for 4 years, we'd be awesome at mental math. Okay, so yeah, divided both those numbers by 2. Is everybody okay with that?
But what if you wrote it as 22 to 32? Would you still have to reduce it?
Yes, I would still have to reduce it. And then I would either have to know to type it into my calculator as a fraction, or I would have to know how to reduce by hand.
Oh, okay.
But it would still be 11 to 16 as my final answer. So
Okay.
this is an acceptable final answer, and so is that.
Okay.
Is that cool? That was a really good question. Okay, so we have our males on part B. Thank you for putting up with me moving backwards and forwards. I apologize. We have our males as 10 males. Everybody understand where David got that 10 males from? Ladies, does that make sense?
Yes.
And David, you had originally said 22, and then you changed your mind to 32. How do we know that this problem needs to be 32?
It says, what's the ratio of employees?
That total that they're looking me to compare it to is the total employees. So I needed the total employees at the bottom. Cool.
And then the final answer, wouldn't it be 5 over 16?
It sure would. If you reduce 10 over 32, whether you do it by hand or in your calculator, you are going to get 5 out of every 16 employees are male.
Cool.
Okay, now Debbie, compare my language in the last one. What ratio of the employees are male to my language in the next one? What is the ratio of males to females? On this one, they very specifically told you what to put on the top and what to put on the bottom. Males to females. Do you see the word to?
Yeah.
Anytime you see the word to, you're going to go in order. It's not saying what ratio of the employees are male. It's not saying what portion of this total are male. It's saying what is the ratio of males to females. So they want you to put the males on top and the females on the bottom. So when it has the to language, you're going to want to go in order. Yeah, and that's the confusing part of this. So if it doesn't have the to language, then you have to translate the problem and try to figure out which part is the total and which part is the piece. But if it has the to language, you're going to go in the same order. Okay, so what is the ratio of males to females? We'll start with the males. How many males are there?
10.
Cool. And then we'll put that in relationship to the number of females. How many females are there?
22.
22. Beautiful. And then we should reduce if possible. And again, if you type this one into your calculator, it will reduce. You should get 5 out of 11. 5 males to every 11 females. And Debbie, I never even thought about in my life how confusing that is, but it sure is confusing that sometimes I care about the of and sometimes I don't. And again, let me see. Let me look at this wording again. What ratio of the employees are male? What is the ratio of males to females?
So of and is.
Say that again.
Of and is.
Yeah, it's that combo of and is, isn't it? But I'm just going to write it down to think about it later so you guys don't have to deal with me thinking about it now.
It was confusing for me too what I read in, but when I see the work that you've been doing is what I figured out.
Yeah, it's making more sense?
Yes, because we have the females and male.
Yeah.
Yeah. When they specify this to this, we don't have to do any translation. We'll just go in order. But when they don't, that's when we have to translate. It's usually piece over total. If they don't specify, we'll put the piece over the total. So yeah, but I'm going to think on that and see if I can make a clarifying video on it. But for now, let's go ahead and see if we can try the next one, letter D. So it says, what is the ratio of females to males? And they were very clear with us. They said they want females to males, so we can totally do that. We'll start with the females, which is
22.
22, and we'll put it to the males, which is
10.
10, and it's almost identical to the last problem, except the bigger numbers on the top. And I just wanted you to guys be okay with that. A lot of students are so scarred by their third grade teachers, they think that you can't have big numbers on the top of fractions, and you can. It's totally legit. It's okay. Please don't convert this to a mixed number.
You don't want to, no?
Relationship between two things.
Okay.
Okay. Is that cool?
Yeah, I was just about to ask that, so. You're just looking for the ratio, not the mixed number.
Yes, leave it as a pure fraction if I ask for a ratio.
Okay.
That's good. Let's take a note of that, David, because I think that'll confuse a lot of people. Leave as a pure fraction if I ask for a ratio, because it's only the pure fraction that maintains that relationship. Okay, last one. It'll be a short class. Hallelujah. So number 7, it says, for every 3 hours Kate spends in the classroom, she spends an hour and a half lesson planning. Now I'm being a little more bratty. I'm being more like the GED. I'm throwing a little fraction at you. Okay, if a semester consists of 32 3-hour classes, how much time does she spend lesson planning over the course of a semester? So I could do this with a tape diagram, but I really want to graduate a little bit from just drawing pictures because I do not want to draw 32 pictures. I don't know how much time that you guys need for most of the problems on your GED, but you don't have time to draw 32 pictures. Okay, but let's make some assumptions based on what we would be doing. And David, you already show me that you have a tendency to get relationships. So good for you. Hold on one second let me catch everybody else up to where you might already be, okay?
Okay.
So for every 3 hours Kate spends in the classroom, she spends an hour and a half lesson planning. Okay, so there's the relationship written once. Now I said a semester consists of 32 3-hour classes. So if I wanted to do a tape diagram of this, I would have to draw a 3 32 times. So how many, if I drew the 32 times, how many times would I draw the 1.5?
32.
32. I would also draw, yes, I would draw the 1.5 32 times. So I would do 1.5 hours of lesson planning 32 times throughout the course of the semester. And so I put times 32. I'm going to do 1.5 32 times. That means 1.5 times. We can type that into our calculator. Whether you write it as a decimal or a fraction, you can type in mixed numbers into your calculator. The way to do it is to use the UN/D button. Now, you guys might notice that UN/D is in green right over the N/D button. Do you see it? If you want anything in green, you need to press the second key. So I'm going to press second, and then UN/D, and then I'm going to arrow around to get the 1 and 1/2. And then I will times it by 32. And I want you two ladies who have your calculator to try that too, because typing in mixed numbers is a little bit of a challenge in this sucker, but how nice that it will do fraction math for you. And I forgot to write down that I did times it by 32, and I got 48. Are you able to get 48 out of your TI?
I'm still struggling with my calculator.
Let me write it down. First, you're going to press the second button. That's in green. Then you're going to press the N/D button, because right above that is the mixed number, UN/D.
Yes, I get it.
Cool. Then you're going to arrow around, putting your 1 in for U, the 1 in for N, and the 2 in for D. Now, this is the trickiest part. You have to arrow right to get out of the fraction before you press times 32.
That's what I wasn't doing, is pressing right.
Yeah, we're not used to arrowing around. Look at where you're blinking, and you don't want to do math inside a fraction. You guys think you can't do math inside a fraction. You sure can. We're going to see more and more complex problems as we go. So just arrow out before you press the times. Okay, is everybody good with that?
Yeah.
Were you able to get 48 out of your calculator?
Yes.
Now, half the internet is so mad at me right now because they are saying to themselves, Kate, I would never have typed in 1.5. I would have typed something else in. Okay.
That would be 1.5, right?
Yes. So if you thought of it that way, you are totally welcome. You will get the same answer. 1.5 times 32 will give you the same thing. If you are just have it memorized, as a lot of students do, that 1/2 is the same as 0.5. So 1.5 is 1.5. Good for you. And you took less time on your calculator, but we're going to get to the same place. So this is 48. Well, this is 48 hours of lesson planning. And I probably do more than that. So thank you for joining me in virtual GED class. Join me next week when we start looking at equivalent relationships and ratios. Turns out that we can use this idea of equivalent ratios and relationships in word problems, and those are known as proportion problems. So we're going to step this skill up one more time and do some proportion problems next class. That being said, if you've never done this before, I actually have homework. I never assign homework, but if you want to be in next week's class and you've never done this before, I highly recommend that you look at solving one-step equations and solving proportion problems algebraically. I have 2 class videos you'll want to see so that you don't get lost next class. All right, see you next week.